about the relational databases in databases, the structure of a database, entity relationship diagrams, and identifying relationships between entities. This lesson also covers database management, where we will be defining databases, figuring out what it is, and the role of database administrators. Lastly, we'll cover tools for managing databases, as well as database programming languages such as SQL. So a big warm welcome from all of us here at Show Academy, where we are here to help you learn the skills you need to succeed today. So once again, let me take this time to introduce myself again. My name is Rushan Weingard, and I will be your technology educator for this course. I also have more than 3 years of industry experience as a lecturer, and I have worked in a variety of settings. This includes IT project management as well as software development. I also have a massive and undying passion for both technology as well as teaching. So for today, we'll be moving forward with databases, which is our lesson 4. Without further ado, let's have a look at some of the objectives for today's lesson. But before we do, let's just ask ourselves a question, because this is something I want you to keep in mind as we progress through this particular lesson. And I want you to think about, why is it that over these last couple of years, as of recent, data has become significantly more valuable than what it used to be? And the way we need to think about this is we need to think about data as some sort of commodity, which we'll cover at a later stage as well. But essentially what happens in today's age is that we have so many repositories, so many applications, so many streams of data coming in from various applications and platforms, from users into organizations. And essentially organizations use this data to drive their strategies, or to refine their strategies, or even develop new strategies within their business. And this makes sense if you think about it, because tech companies, for example, might require a lot of data to refine the technology processes. If you think about it, it kind of makes sense. So essentially what we have is this whole domain of big data, and all this data sitting there, but we don't know yet what it is that we need to do with this data. So we apply things like algorithms, machine learning, artificial intelligence, and all of these fancy things to our data to tell us some sort of story. Right? Now, big data is something we'll be covering at one of our later lessons. The idea here is essentially for you to just ask yourself, why is data so valuable? And essentially because organizations use data for various reasons, whether it's problem solving or to enhance a specific process within an organization. Great. So let's have a look at our lesson 4 objectives for today. First, we'll be covering data. And essentially what we're going to do is we're going to try and define data. We want to understand data and what the difference between data and information is, for example. After this, we'll tackle relational databases, which is a very, very, very common database architecture within many organizations, right? The nice thing for today's lesson is that we'll also have a practical component where we'll design our own entity relationship diagram, which we call the blueprint or the schema of our relational database. Following this, we'll cover database management. We'll have a look at some of the tools in database management and what are some of the roles in industry and what are the people that actually work with databases. Great. So let's get started with our first topic, data. And what is data? And why is it so important? Well, we just covered that briefly in the question that we posed, but let's dive a little deeper, shall we, on a more definitive approach. So data versus information. Essentially, data refers to any raw facts, right? And raw facts can exist in various formats. This includes things like numbers, text, decimal points, audio, and so on. And let's take an example where we look at numbers or decimal points, for example. If I, for example, had a table of 50 just random numbers, just 50 numbers, right? If we consider that, there's no sort of context to that. All we are looking at is essentially just a table of numbers. Now, let's say these numbers are in degrees Celsius, for example, or Fahrenheit, the temperature, right? Again, we have data, but although we've added context, or although we've added some sort of measure to it, all we know is that the data represents some sort of temperature. Great. Now, on the other end of the spectrum, we have information. And information is the result after data has been processed, after data has gone through some sort of process, we now have some sort of meaning and context that we can actually add to our data, right? And data is basically the foundation of information. Without data, there is no way that we can end up with information, because we essentially need to process data to get to information, right? And then information requires context to reveal meaning. Great. Now, if we go back to the previous example where we said we've got this table, and in this table we have a record of 50 numbers, 50 figures, and all we know is that they are temperature values, right? Let's say degrees Celsius or Fahrenheit, for example, again. Now, if we had to add this data to a graph, and on the graph we have our y-axis, which is the temperature range, for example, and on the x-axis we have, let's say, a number of years. And let's say the title of our graph is temperature in, let's say, for example, in California from 1990 to 2010. Great. Now we've got information. Now we've got a story to tell with this data. Because on our x-axis, we've officially plotted all the temperature values. On our y-axis, we have the number of years ranging from 1990 to 2010, as well as a heading that officially tells us that this data has been gathered from California, or in California, from the year 1990 to 2010. Now, instead of just having values, temperature values, we have the story to tell, where we can actually say, hey, this is California, and in California from 1990 to 2020, this was the temperature range. Right? And this is important to understand. This is how we distinguish between what data is and what information is. Data is essentially an input to information. Information gives us some sort of meaningful story to tell, which allows us to build some sort of knowledge base. Great. So also, organizations use data as part of strategic decision making, and this is something we mentioned briefly earlier. And the reason for this is no organization is just going to make a decision without having some sort of data, without having some sort of understanding. And this is why data is so important to organizations, because organizations look at data, whether it's past or present data, to make strategic decisions that are healthy for the organization overall. Right? Also, information needs to be accurate, relevant, and timely. Now, this is key, because any organization will not make strategic decisions based on old data, or it could be old data, but if the data is inaccurate, if the data is irrelevant to what the organization is trying to achieve, and if the data isn't delivered in a timely manner, then the data or the information can't necessarily tell the kind of story to its full capacity or to its full spectrum, if you will. Okay, so I know this is a lot to take in at the moment, but I hope this makes sense in just distinguishing between data as well as information. Great. So we've got this thing called data processing, and we need to understand what is data processing. So, or we can even say processing data. So data processing is the conversion of raw data to a meaningful sort of knowledge base or information base. And this is what we just discussed. So we essentially use computer-based systems and software to take in data as an input, transform that data or process that data using some sort of algorithm, for example. This could be artificial intelligence or statistical algorithm. And after these operations are carried out on the data set, the data is then sort of cleansed and it's given to you in a meaningful way, right? So again, in most cases, organizations use systems and software to carry out a number of operations on data to present, interpret, or obtain information. This includes activities such as data entry, summary, calculation, and storage. And the idea again is to get some sort of useful information out of that. And how do organizations transform that data into information to give meaningful context? By the use of reports or diagrams or graphics or graphs and all of these kind of things. And we generally would refer to this as business intelligence, for example. Now, we've talked about this thing called processing data, and much like producing a tangible product, processing data is sort of like a life cycle, if you will. And with any life cycle, there are various stages in a particular life cycle. Now, when it comes to organizing and storing data, or the life cycle of processing data, there are 6 steps involved. generally speaking. This can be flexible, right? This includes things like the collection of data, the preparation of data, inputting data or retrieving data from its input sources, processing data using actual machines and computer systems, outputting data, as well as storing that finalized data. So let's start off with the first step. So when we talk about the collection of data, we are basically talking about one of the most important parts of the life cycle, because data needs to be accurate. And this is extremely important, because if data is not accurate from the jump or from the get-go, this can cause issues down the line when organizations make strategic decisions based on this data. So data must be gathered, and it must be accurate and well defined throughout the life cycle. In the preparation phase, we are basically referring to things like constructing a data set from one or more data sources, right? And when we talk about data sources, this can be from an application, from the web, from a form, from the user, whatever the case is, right? We have to prepare this data from the various sources that they're actually being captured from. Then inputting data is the task where data is verified or coded and converted into machine-readable form so that it can be processed at a later stage by an application. So data entry is done through the use of either a keyboard, a scanner, or any sort of input device. If you look at our lesson 1, for example, when we covered hardware and software, we spoke about hardware in the aspect of input devices and output devices. And essentially what we're saying here is that the way data gets inputted is imperative, right? And this could also be from various sources. Then we move on to the step where we process data, or processing data. And this is when data is subjected to various means of methods of powerful, like really powerful technical manipulations using algorithms or software, where the data goes through this entire operation to be processed and then give you some sort of informative story. And this essentially leads us to outputting data, where data is presented to users in the form of graphs or figures or illustrations, diagrams, or whatever the case is. Again, this is often the case when it comes to things such as business intelligence. Now, finally, after we've processed our data, we've captured our data, we've processed it, we've outputted it, in future, we might want to refer back to that data at a later stage. And to do so, we must effectively store our data for later retrieval at some point, right? So just a quick fact about data. And I think I might have given this one away. But data has become a commodity. So as of recent, data has officially become more valuable than oil, right? This means that data is now more valuable than what used to be the world's most valuable commodity, that being oil. So in the last 2 years or so, 90% of the world's data has been generated just within that 2 years. That is the velocity, and that is how much data is being generated worldwide as of today. Because of all these applications and all these online platforms, we have so many data sources where data is just being pulled from and being processed for some sort of reason or whatever the case is. So this also allows for new marketing channels and technologies that are popping up all the time. Things like your social media platforms, your tech companies, and all of these things, right? These channels have now created new means of gathering data. And then today, marketers, social media marketers, for example, will use this data to formulate things like their marketing strategy or whatever the case is. Now, before we carry on, if things do become a little tricky, this particular lesson can be quite technical, especially when we get to the practical part. Don't forget that Morpheus is there to help you throughout the entirety of this course. So if you get stuck, if you have any questions, please feel free to pop your question into Morpheus and we will address your question if Morpheus can't as soon as we can. Awesome. Now for our next topic, relational databases. And this is quite important because this is where things are going to get slightly tricky when we get to the practical part. Okay. So what are relational databases? First of all, let's start off with the structure of a relational database. And we have a very brief definition here, right? So a relational database is one that is highly useful to organize data into collections of two-dimensional tables called relations. Now, that is a very vague definition, but I've kept it vague because I want to give you guys a visual explanation of the characteristics of a relational database. This also defines the structure. But essentially in a database, if you think of an Excel document, you have multiple sheets that you can connect to each other. You could consider this a flat database, or you could consider this a database. A relational database, however, is slightly different because you can add things like constraints, primary keys, foreign keys, and the terminology varies slightly when we talk about relational databases. So what are some of these characteristics when it comes to relational database? So a typical relational database consists of multiple related tables, very, very important to keep in mind, also known as entities. So in relational databases, when we talk about tables, essentially we are talking about entities, and an entity is an object that you want to capture information on. Right? Now, this comprises, or an entity and a table comprises of multiple records and fields, as well as things like primary keys, foreign keys, and so on. So let's work through the list of characteristics that we actually have, starting with an entity. If we look at our diagram on the right hand side, we have two tables called a customer table as well as an order table, right? And in this table we have attributes known as customer ID, first name, last name, address, address to. And then in our order table we also have attributes called order ID, description, price, and so on. Now, you'll note in the customers table, we highlight customer ID as a primary key. What is a primary key? A primary key is a unique identifier associated with a record. If we think about your social security number or your identification number, essentially you have that number and no one else has it. That is how you are able to be uniquely identified. In this case, we have customer ID 10 to 13. And those numbers are never repeated throughout this table ever, which means Jackie, Bob, Peter, Alexis each have their own customer ID. Great. So that's the primary key, right? A unique identifier, golden rule in databases. And then moving down, we have this thing called a record. A record is essentially one full row of data. Let's take Bob's case, the one that we have highlighted. Bob's record is his customer ID is 11. His first name is Bob, his last name is Smith, and his address 1 and 2 is Swiss Road, London, respectively. Great. Now, before we carry on to all the other characteristics, I also want you to take note of the foreign key. So if we look at our order table, for example, our last column in our order table on the right-hand side, what we'll see is that there's a thing called US customer ID, and that customer ID is linked with customer ID in our customers table. Now, just take a second to think about this. One customer can have multiple orders, right? But in the customer table, a customer can only exist once, if that makes sense. Now, the reason we use primary keys and foreign keys is because if, for example, we wanted to find out what, let's say, Bob ordered, right? And what we essentially could do is we could use this primary key as a reference in our order table, which is our foreign key, to actually look up who customer ID 11 is, and that person bought a cupboard. The order ID of that is 101, and we see the customer ID associated with that is 11. Now, if we look at our customer table, we can actually see over there that, hey, the customer that ordered this black cupboard of order 101 is Bob. And this is how we associate relationships between tables, right? If we move further down, we also have this thing called a field. A field is essentially a cell, if you will, or the equivalent of a cell in Excel, right? And a field is just one item of data. In this case, we have Alexis, and then we have Peter, or we can even consider the customer ID number. Just that single instance is considered a field, for example. Okay, and then last we have this thing called an entity, which we refer to as an entire table. Now, an entity is the item that you want to capture information on. In this case, we have an order table and a customer table. Great. So in these two tables, we can consider the information that we are capturing on each entity is things like customer ID, first name, last name, and so on. Now, this is very, very important to understand as we move forward with ERDs, or entity relationship diagrams. And again, if you don't grasp all of this immediately, it's okay, because when we get to the practical, hopefully all of this starts to make a bit more sense to you. Awesome. So we've spoken about this thing called an ERD, or an entity relationship diagram. So let's just define it and figure out exactly what it is. So an ERD, or entity relationship diagram, is essentially this blueprint or the structure of our database. Let's consider it a snapshot or a schema of our database and the flow of our data and how entities are related. So ERD shows the entities or the tables in a database, and then we get this grasp of how these tables are related, which data flows which way, right? And for a good database design, it's extremely imperative, extremely important to have an ERD or an entity relationship diagram, because in future, if we want to configure and tweak this database, this blueprint essentially allows us to figure out what needs to be changed, right? Sort of like an architect building a house, if you will. And in this example that we have on our right hand side of our ERD, what we have is this thing called customer table, a product table, a shop table, a vendor table, and a sales table. And these lines running between these tables are the relationships between those tables, right? At the end of these relationships, you have these weird looking figures that looks kind of like a crow's foot. We call this the crow's foot notation in ERD. And this establishes the relationship between various tables or entities. Remember these blocks that we have over here? These are called entities or tables. In the customer table, for example, we capture information like phone number, customer number, name, and address. In our sales table, for example, we can immediately see we've got a foreign key called product, for example. We've got a date type of data in this table, as well as the sum total. So how do we kind of define these tables and the relationships between them? And what I want to do is I want to go through this graph with you, or this illustration with you, before we actually move on to the practical task. So when we identify relationships, essentially what we're doing is, when we're designing a relational database, the best way to resolve a relationship is to create a logical set of business rules, or enterprise rules is what we call them as well. And a simple example of an enterprise rule is a customer can have many orders, or an order can consist of multiple products, right? Essentially what we're doing is we're enforcing a rule, we're stating this logical sentence, and now we're saying this is the relationship between these two entities. Let's look at the customer again and the order. What we are saying is that we've got this entity called a customer, we've got this entity called an order. Here's the business rule. A customer can have 0 or many orders, but an order, a single order, can exist only to one and one customer. And therefore we have these rules at the bottom that says things like 1 to 1, 1 to many to many, as well as optional, right? And if we look at our diagram or our illustration at the bottom, what we have is these crow's foot notations. These are essentially the different crow's foot notations or relationships you can establish between two entities or two tables. First, we have 1, which basically says, for example, an order again can only belong to one customer, right? Then we have the many crow's foot notation, which states that this relationship means many, more than one. So this instance of a customer, for example, can relate to an order many times, similar with the product and the supplier, right? And then we have the one and one only relationship, which basically says something can only belong to another entity or another table, or the record for that item can only exist once and only once, if that makes sense. Then we have the optional for 0 or 1, which means not more than 1, only 0 or 1, 1 being the upper limit, or 1 or many. So can occur for one instance or many instances. And then lastly, we have the 0 to many. So again, let's refer to the order and customer, because I feel like this is quite simple. And essentially what we're saying here is that one customer can have 0 or many orders associated with it. And again, this makes sense because a customer tends not to, if he's happy with the product or service, will have more than one order with a particular company, if that makes sense. And if we have a look at the order and products, what we're saying is an order is related to the product in the sense that an order is optional, right? And the product is at least one or many. So an order can consist of one or many products, is what we're saying, right? And we look at the supplier and product relationship. What we're saying is that one supplier can sell to a company one or more products. Great, so I hope that makes sense. Now, without further ado, let's actually dive into building our own ERD. And this is going to be quite exciting. Now, I will walk you through this tutorial from scratch. I will show you which platform to use, and we'll design it based on a set of business rules. And we'll try and keep it very simple for the time being. So, without further ado, let's get to our quick practical for this lesson. And essentially for this lesson, what I want you to do is you can either follow along or you can watch the video and then attempt it all on your own if you'd like to. It's entirely up to you. So essentially what we're going to be doing in this practical is we are going to be creating our own ERD, entity relationship diagram, using Lucidcharts, right? And what we have over here is a bunch of business rules, okay? So if we read the sort of mini assignment or practical, what it says is that consider the following business rules and create an ERD to visualize the relationship between the relevant entities, and use Lucidcharts to complete this. So before we even get into actually designing our ERD, let's have a look at what our entities are. And we can generally see our entities are any sort of objects that we want to capture information on. In this case, we have students, so we know that's one. So maybe let's just highlight, we've got students. We've got this thing called a faculty, okay? We've already got faculty. We've got courses. We'll just highlight courses. Right, and this is just an easy way to identify your entities before you start designing your ERD. And then lastly, we have lecturers. Oh yeah. Great. So now that we've highlighted all the entities we're going to work with, let's have a look at the relationships as we actually build our ERD. Now, if you want to find out where Lucidcharts is, or if you want to use Lucidcharts, you can simply just Google Lucidchart. It's basically the first link over here. Of course, you'll have to register. I generally suggest just using the free package because you won't necessarily be using this for complex things in this tutorial. Okay, and the first thing I want to go ahead and do is I want to create a new Lucidchart. So I've already registered, as you can see. I'm just essentially going to go and create a blank document, right? So the first thing I do is navigate under the new tab, click blank document. And once it starts loading up, we can then essentially get started. All right. Now, a couple of things to note here in Lucidchart is we've got all these shapes, and these shapes give us some sort of meaning to what we're trying to do. But here we've got standard, we've got flowchart, we've got shapes. We are not interested in working with any of these. Since we're working with an entity relationship diagram, we can just go ahead and close all of that off. Right. And then the next thing we want to do is click on the shapes button over here. Navigate to entity relationship and then use selected shape. All right, and then we'll be presented with this little panel over here with the various shapes that we can use. Since we're going to keep it very simple, I'm going to just go for the most basic one. Okay, and I'll drag this over, and you'll see the things it's asking me for is the entity and the fields or the attributes that I want to capture information on. So if we navigate back to this over here, we've got student, faculty, courses, and lecturer. These should actually not be plural. And so let's just going to delete that. So first thing I'm going to do is I'm going to create a student entity. All right. And then remember we spoke of this thing of primary keys and foreign keys and the fields that we want to capture. Over here, I'm just going to go ahead and say, maybe I'm looking for the student number. Right, so I'll just type in student num, and then we don't necessarily need all these fields because for this example we're only going to be working on building the relationships. So I'll go ahead and delete this row, and maybe over here I'll just say name. Right, and to keep things simple on a Windows system, you just hold down Control and Shift. I'm not entirely sure how this works on Mac. Then you can drag it out, right? And we'll create 3 more of these for the other entities that we want to work with. And then we can just go ahead and rename these. We also add, what was the other one? It was faculty. So we're going to say faculty. And then we'll just change this over here to something like faculty ID, right? a faculty also has a name, so we can keep it as is. Then we'll go ahead and change this one over here to lecturer. Oh, if my spelling could just be awesome today. Lecturer. And we can just say a lecturer has an ID as well. So we can say lecturer ID. And lecturers also tend to have names, so we'll keep the naming field as well, or the name field. And then lastly, we add this last one called course. And let's just say course ID. Great. So we've got our entity set up. Oh, and keep in mind that a course also has a name, so we'll stick to that. We can also have things like student last name, faculty location, or, additional fields if we want to. But again, we're trying to keep this very basic. So I'm going to hold down and drag a couple of these things. I'm going to plot my faculty over here. I'm going to, let's just keep this uppercase for consistency's sake. Lecturer, I will keep, let's just drag it down maybe, so we can give our diagram some more visuals, and then maybe we'll plot this one over here. Great. So now we have our entities. Let's review our relationships. So our relationship here says 0 or many students can belong to one and only one faculty. So there automatically we know the relationship based on our business rule. So what we do is we highlight one of these dots over here, and we just drag a line straight through, and we now have a relationship between student and faculty. The default relationship in Lucidcharts is one to many. Okay, we want to change this, and what we can do to change this is over here, once we highlight our relationship, we can choose the endpoint and the endpoint over here. Right, or the start point and the end point, if you will. And essentially what I want to do is I want to change this to 0 or many students can be allocated to one and only one faculty, which makes sense because you can't be registered in two faculties as a student. It doesn't make sense. You can't be doing something in, let's say, arts faculty and maybe the science faculty. It's near impossible. Okay, and for the next one, we'll just go and structure our faculty over here. Let's drag another relationship out. And essentially what we want here is that, let's have a look at our business rule for this one. One faculty can house one or more courses. Okay, so we'll say one faculty, which we already have, right, can house, what was that relationship? Let's just double check. One or more courses, right? So we have to change this relationship over here because this one is just many. What we're looking for here is one or more. And again, we'll just go hit up on top over here and we'll change that to that. Great. So half the work done. And next, we want to look at our next business rule, which says one or more students can be registered for 0 or many courses, which makes sense because you could still be a student at a university with an existing student number or student ID or whatever the case is, but you might not be studying for that year in a particular course. This might vary depending on university policies, but from most universities that I've worked with, this is generally the case. And now we want to, that relationship, let's just check it out again. One or more students can be registered for 0 or many courses. Great. So I want to drag the relationship from here, and instead of dropping it onto this one over here, right, because you'll see over there that line merges, which makes it hard to see what's going on. What we can essentially do is we can just drag it to the corner block over here. Great. So let's maybe see if we can just move this over slightly. Oh, that doesn't work. Let's just keep it as is for now. Okay, great stuff. So we said the relationship we wanted here is one or many on this end. So we can go ahead and highlight this and we can say one or many can be studying or can be registered to 0 or many courses. Great. Now for our final relationship, we've got this business rule that says one or more courses can be taught by one and only one lecturer. And again, this makes sense if you think about it, because a lecturer might be an expert in various topics, therefore they can teach various courses, but then only generally speaking, one lecturer would be assigned to one particular course. So let's just kind of build this relationship out. Let's configure this relationship, and we want a one and one only on the side, and we want a one or more on the side. And there we go. So effectively, we've now allocated our business rules. We've taken our business rules and we've built an ERD based on the defined rules. Okay. And essentially what this shows us is the flow of data, how data flows through a relational database. Again, you could add multiple fields here. Your relationships could vary. It's not to say that these rules are fixed or static in nature. It really depends on the organization. An organization's rules will differ from one organization to the next. So the idea here was essentially to show you how we build a relational database schema or an ERD by understanding the flow of data. So I hope this lesson helped you out. I hope this practical has given you some insight. Moving forward in the future with other modules and other lessons, we'll try and formulate more practical skills so that you guys can actually take something from this course. So before we proceed with our final core topic for the day, let's have a look at what's coming up in lesson 5. So in our next lesson, we will have a look at traditional data versus big data. We also explore how we process big data and traditional data, and we also follow up on the 3 V's of big data. You'll also learn about tools for big data management, such as the use of software applications and how it is that we can do things like data visualization. We also explore things like business intelligence and machine learning and how these things can be applied to get more insight out of our data. In lesson 5, we also cover how to use big data to formulate organizational strategies and how big data is used in industries such as social media, e-commerce, and healthcare. So with that being said, let's move on to our final core topic for the day, database management systems or database management. So what is database management? Database management refers to those individuals or the processes involved in organizing and managing and designing an effective relational database, for example. So one of the most prevalent roles out there is that of a DBA, a database administrator. And essentially what these individuals do is they work with users within an organization to define the data needs, what kind of data is that the organization needs to run successfully. They also identify the entities of interest. Remember, entities are referred to as tables. So the objects of the information or the objects of the organization that you want to capture information on. These individuals also apply programming languages such as SQL to manage databases effectively. They test and evaluate databases, especially in the event if databases need to be redesigned, for example. Furthermore, they also implement changes to the database. Again, this goes back to the previous point, in the event that databases need to be redesigned, revamped, or tweaked, or whatever the case is. And then lastly, they ensure unauthorized access to databases. So they are sort of the gatekeepers of a relational database, if you will. Great. So now that we've gotten an idea of what these employees that work with databases actually do, it's important to understand what a database management system is and what are some of the considerations when building a relational database or database management system. So a database management system is a collection of programs or applications or softwares that we tend to use to manage the structure and the control and access to data. So again, here are some of the considerations that one tends to take in mind as a database administrator, for example, or a database designer when creating a database. So one thing we must consider is the kind of content that that database will hold. What information is that we're trying to feed into this database at the end of the day? Also, who has access to the database, who has authorization, and on what level do people actually have the need to access the database? For example, in an organization, someone that works in HR might not have the same access as to someone who's an executive within an organization. And then also the physical organization of a database. Should the database be centralized, distributed, decentralized? These are some of the questions you must ask yourself. And then lastly, the logical structure of the database. The schema, if you will. Similar to the ERD example that we just did, the logical structure speaks to how the data flows throughout this particular database that you've built. Awesome. So what are some of the types of database management systems out there? We generally work with 3 overall, and this includes single user databases, multi-user databases, as well as flat files. So let's distinguish between the 3. In the event of a single user database, we are talking about databases that tend to be used for individual purposes. And this could be something like MySQL when you're practicing to build your own website. These databases aren't necessarily scalable because, again, they are meant for single user applications, whereas multi-user databases or management systems gives you that scalability where many, even thousands or hundreds of thousands of people can access a database to do some sort of task. And these databases, again, are a lot more scalable as opposed to your single user databases. Now, we also have this thing called flat files, and this is how we traditionally used to manage data. And flat files aren't necessarily a relational database. They are more like your text documents, for example, that can hold things like data, whether it's numeric, text-based, or whatever the case is. Great. And then lastly, we've also got tools for managing databases, right? And 3 popular applications out there are MySQL, Oracle XE, and Microsoft SQL Server. Now, MySQL we tend to use for small web development projects. Now, they might be slightly scalable, but they're not all that great when it comes to massive projects. Because Oracle at the moment, Oracle is one of the leading database providers out there, and they offer applications from business intelligence tools, data mining tools, multi-dimensional tools, and essentially you would use all these tools to build on top of one massive big application. And Oracle is perfect when we're talking about massive organizations with thousands and hundreds of thousands of individuals that work within an organization. And then last, we have Microsoft SQL Server. Now, there's not much to distinguish between Oracle and MySQL Server because they are both used for massive databases. The only difference is that Oracle and MySQL Server, the architecture varies, the syntax is very much the same when it comes to programming languages, and they are both meant for big organizations. Again, the key difference here is that they belong to 2 different providers. Awesome. So what about SQL programming when it comes to databases? So we have this thing called structured query language, and this is an information systems special purpose programming tool that we use to access and manipulate data in a database. Now, what are some of the things we can do with SQL database programming? We can select data, much like the tables we presented earlier, where we could view data in a table structure, for example. We can also project data, so we can eliminate some parts of the data and only show certain parts that we are interested in. And then we can join various tables to show us a more streamlined data set. Now, this topic is specifically very technical when it comes to programming languages. So for the sake of this lesson, we won't be covering any of those things here. Great. Now that we've come to the end of our final topic for this lesson, I'd like to remind you that keep in mind, should you have purchased your toolkits, it's really going to help you move forward and progress more effectively because you'll have all the resources you essentially need to complete this course. So all your summary notes, your lesson slides, everything becomes available to you should you have purchased your toolkits. And believe it or not, students who purchase the toolkits are more than 5 times likely to achieve their goals in this particular course. So just something to keep in the back of your mind. Great. So now that we finish our 4th lesson, keep in mind after every 2nd lesson, you have a lesson assignment due, and you can essentially find this in your dashboard once you've completed this lesson for today. So a big congratulations for making it halfway through this module. You've just completed lesson 4, and honestly, you should give yourself a big round of applause. Keep in mind, in our next session, we will be covering big data, traditional data, and that lesson will essentially build on what we've done here in lesson 4 today. So for all of that and more, I'll see you in the next lesson. Goodbye.